There we are. So we'll just talk a little bit about Lustre transitioning to folio-based I/O from struct page. So why are we doing folio? Well, upstream won't accept us if we don't do it. So that's the first reason, now that folio is the standard. And the second reason is kernel support. Many of the APIs have switched to struct folio, and as more file systems get converted, it becomes more and more difficult to do the kernel support just because the APIs keep going away, and it's harder to get pages. So the first order business, when we're moving to folio order 0, direct I/O was our first complication. So in direct I/O, we grab user pages, but those user pages are embedded in large folios. And so we need to track the page or the offset that that folio came from and plumb that through Lustre. So then the next stage is buffered I/O, and the rest of buffered I/O is pretty straightforward. The main challenge is really just the number of places of code we have to touch and getting reviews and moving things through. It's mostly name changes, API changes, and making sure that we're backward compatible for older kernels. So, yeah, so aside from the general friction, we're moving pretty quickly. Tests are passing for order 0, so it looks ready to be landed for 218. Large folios, greater than order 0, like DIO. That was my first approach, was the idea that, well, if it worked for DIO, maybe I could do the same thing for buffered IO and just track the page offset and create a bunch of CL pages, and that got worse and worse as I went along. More and more special cases, more and more quirks, and it's not a good idea. So where we're at now is use CL page, just one folio per CL page, so we could probably call it CL folio, but that'll require another patch. So now we take the folio and we push it all the way down and we to the block to the BRW, and so we have a few issues. Not all I/O starts at folio boundaries. Sometimes we have to track that our write is one page in or 2 pages in on a large folio. Sometimes they don't cover the whole folio. So most of those things are normal, but a few of them cause us some issues. So mmap page faults arrive in page-sized chunks, mostly. And places where page size is assumed just needs to be adjusted for large folios, determined if that's still something that can be treated as a page or if we have to check the folio size. The OSC extent grows in multiple pages now, so this affects grant handling, so we have to calculate grants a little bit different because we are dumping a bunch of pages at once instead of just one at a time. CL page list, OS extents, BRW page, I called it extent now because it's no longer a page. Now include the number of pages along with the number of entries. So, how does this work with encryption? So now we have, whenever we copy in, copy out, do our T10 diff handling, we all need to walk a nested loop of BRWs so we have to walk all the pages and copy them in and out. All of the encryption is still page-oriented, even as some APIs are coming in now where the FS crypt can handle a folio being passed in, but it really only handles one page at a time. And all the bounce buffers are all order 0. So we have to keep a little track that we're breaking up a folio into multiple. So let's see, yeah, we renamed BR page because it's no longer page. There's some read-ahead adjustments because we're not, we have to calculate things a little bit differently because we're reading in possibly large chunks and not a single page. So there's little caveats in the read-ahead code, not too much. So when we fault in a page on the read side, most file systems fault in the entire folio, whatever that size is. So we just read the whole page, read the entire folio, not a single page of it. And then we have another caveat with PCC. The backing file system should align the folio, our folio order. So if we say, when we set up Lustre and we say, oh, we take large folios of a certain size, we tweak the PCC backend to do the same thing. Yeah, so we track the offset and length. We need to pass that down for short writes. The OAP page offset and from and to can all be larger than a page, so those all get resized. I do have a question when we get encryption and compression. If the BP count diff and BP off diff, they're currently 16 bits and they probably need to be increased. And some BRW gets some additional pages, some flags added, and that's it. So, questions?
Two questions. One, historically Lustre's been used mostly on systems with 4K page size, and I know some newer NVIDIA systems are 64K page size. Does that have any kind of impact on any testing or development that you've done?
So far, I think the vast majority of my testing has been on the 4K page system. It should not have any impact as far as what do I do with a large folio. So in the 64K system, the large folios can be quite a bit larger, but I do cap the folio size, I think, to 1 meg. So technically, I think we could go to 4 meg.
That makes sense. About the cap of the folio size, I know LNet RPCs are capped to 1 megabyte right now. It's conceptualized as like 256 times 4K page. I think it used to be just page size, but now I think it's hard-coded at 4K page. There was at one point you could use larger RPC sizes. I think James might have actually removed that, but so I guess I know there's some hardware. I think EFA might be able to go up to like 4 or 8 meg, right? And I suppose. Well, long story short, do you anticipate doing any work to plumb, like 4 meg or 8 meg all the way down through LNet?
Not yet. I was waiting for more of the block layers to adopt more folio direct support. So the SG list is now getting folio support, although it's, again, like the FS crypt, it's still operating on page size chunks. So it's not really an advantage yet, but I assume it will be at some point.
That makes sense. I have another question, but I'll let other people go first.
Oh, and I have a question. So can folios distinguish between GPU type RAM pages and regular pages? Because like we have special GPU flags to see that we're using.
I think all that stuff just passes through.
Okay.
So I think if you want to allocate, the allocation flags are the same. So that I think it should end up being, yeah, it shouldn't really be any different.
Okay. Because I was just wondering if you could allocate from specific pools in memory with folio. Like,
I think you can when you allocate a folio. When we're doing it
Yeah.
from the buffered write path, we just do the standard
okay.
grab a folio maximum size.
Hey, sorry, Shaun, I'm over here.
Oh, okay.
That's Corey again. I don't know if there was more discussion on the GPU stuff, but like, you don't, struct pages, those aren't in the buffer cache either, right? So does that play into that at all?
We don't do anything with things that, this doesn't really affect anything that's in the direct IO path, realistically. Just that we,
So maybe that's an answer for James, I don't know. My question was about performance. Do you have any performance numbers? Do you have any, you talked about the mmap use case earlier too, right? Like, do you have any projections of what this can do for performance cases? Thanks.
well, right now we're still hopeful that we get the general 2x bump that we see with most file systems when they switch to large folios. So I don't have any performance numbers yet.
I had one other question was on the server side. Would we ever use large folios on the server? Is there any advantage or disadvantage or?
Right now, I'm doing everything with order 0 on the server side. In theory, maybe in that case, I suppose we just allocate one large folio, because that's mostly what we end up doing on the server side. Is we just allocate a pool and we keep that pool operating and filling and pushing. So. Maybe if we're doing more of the write-back caching, might make a difference.
That makes sense.
So, I mean, today, ZFS is doing its own thing, so I don't know what the state of folios with ZFS is, but on the LDiskFS side, the OSD is already not allocating and deallocating pages from the page cache, right? So anything that's over, I think 4 megabytes is just going into a dedicated memory pool, and then writing directly to disk. So folios, one of the savings is, of course, the page insertion and deletion from the page cache, so that won't make a difference. But one of the things that folios does enable is large block size for LDiskFS, right? So if you look at these huge disk OSTs, they're in the 1 to 2 petabyte range per OST. They have, 8 million or 16 million block groups, right? And, a lot of blocks. And so if we can reduce, there's the clustered allocation in ext4 as well, but having large block size, like you're saying, the rule of thumb is it's about twice as fast, for doing any kind of large I/O. Of course, the cost is that now the minimum allocation size is 64K or something like that. So, you might want to have large block size for your OSTs, and then have disk OSTs, and then have flash OSTs with 4K, and then you can mix and match, right? And if you round 64K on a gigabyte file, you don't care, but if you're doing 4K files, you know, that's a big difference, right? So I think you'll see some improvement on the server side, but it will be, you know, workload dependent, right? Whether it makes a big difference or not.
This is more speculative. Transparent huge pages. So there's like what, like 1 megabyte or 1 gigabyte pages or 2 gig pages. Do you have any thinking on that? Is there
Well,
any
yeah, the folios basically supersede that. They're basically huge pages, or the ability to treat huge pages as folios. And
Okay, so is there a limit to how large a folio can be?
I think it's a huge page is the maximum folio.
There's a practical limit because you don't want to be doing I/O with 1 gigabyte. Sorry. There's a practical limit because that's the granularity of your I/O. So you have to populate the whole folio from the server, right? So if you make the folio size too big, it means your I/O is going to be really inefficient if you're doing anything other than like linear reads. The good news is you can do folio size per file, right? And so we can do that, you know, mix and match, right? Anything, you know, for Lustre, 64K would be fine because that's the minimum stripe size anyways, which is tuned based on, you know, page size, right? For ARM and things like that. But I think once you get past a megabyte, you're not really going to save very much, and it just makes it clunky, right? Oh no, I read 4K from this file and it pulls in a gigabyte of data from the server, right? That would be lousy. So I think 64K or 1 meg is going to be worth it, but not beyond that.
That makes sense. I guess I have one more question. I have lots of questions.
Sounds like it could be a topic for Developer Day.
Is there any reason why could you use large folios on, you know, like a new client and a much older server? Is there any impact on the network protocol at all?
But it's client only, so there's
Okay.
no issue.
That's what I thought. I just wasn't sure. Because I know 64K pages, there were some interop bugs with those.
Yeah, we had some interrupt bugs with that, and I don't know if they're all completely gone, but they're mostly gone, hopefully.
Hopefully.
Yeah, there's just some weird things that happen.
Okay, I truly have no more questions.
Well, thanks again, Shaun.
All right.